graphing exponential logarithmic functions. So an exponential function is a function where the independent variable, that's an x right there, is in the exponent. So that is f of x equals a to the x power, and the a shows the growth or decay. So if a is a fraction, it's going to be decay, and if a is 1 or greater, it's going to be growth. The domain of that is all real numbers, and the range of that is all real numbers greater than 0. So here's just an example. So we have the parent function, which is that f of x equals a to the power of x. So for a, I just plugged in 3. So obviously it's going to be growth, and there's just a chart showing you what the points would be. So when setting up the chart, it's the x and the y, and then you start with -2, so it's going to be 3 to the power of -2, 3 to the power of -1, and so on and so forth. And that's going to be the graph that you get for f of x equals 3 to the power of x. So here's some other basic function examples. I'm not going to go through each one, but it's just to show you the different ways that a exponential function can be varied and changed. So like the f of x equals 2 to the power of x, that's very similar to the one we just saw, that's that red one. And the green one correlates with the green one that goes right here. The purple, the h of x equals 1/7 over power of x, the purple right there. And the orange graph goes to the orange one right here. The transformations of a parent function. So right here, basically, I just gave you a complex exponential function, and we're going to go through each step on how to graph it. So first of all, you see f of x equals -1/3 times 4 to the power of x plus 2 minus 5. So you see right there that the x is in the exponent, and you know that's going to be an exponential function. Looking based off of the x right there, you see 4 is the base of the function, similar to that 3 to the power of x we saw before. The negative right there shows a reflection across the x-axis. The 1/3 right there shows a vertical compression, 1/3 by its height. The plus 2 right there in the exponent shows a translation 2 units to the left, not to the right, but to the left. And the -5 shows a translation 5 units down right there. So the first step, it's that f of x equals 4 to the power of x. So the graph has a base of 4. Like the first example I showed you with the f of x equals 3 to the power of x. You're gonna to graph that, you could use it on your calculator, or you could use a table with the x and the y values. So that's the f of x equals 4 to the power of x. Next step is moving the graph 2 units to the left. So whereas before it's right there, it moves over 2 spots to about right there or so. And that is that f of x equals 4 to the power of x plus 2, shifting the graph 2 units to the left. The next step after that is vertically compressing it by 1/3. So you get that 1/3 times that previous 4 to the power of x plus 2. That's the graph you get. That's the next step. Next step after that is that negative. So you're going to flip the graph over the x-axis right here. So whereas before you had it like that, it's going to flip over the x-axis, and you will get that as your new graph. And then I believe your final step is the shifting the 5 units down. So you see how it hits the x-axis at 0 right there, x equals 0, and now hits it at -5 right here. So that's the graph shifting 5 units down, and that will be your final function. Next we have logarithmic functions. So logarithmic functions normally have base a, that's like the general term, and they're read as f of x equals log base a of x. The parent function for that is f of x equals log of x with an assumed base of 10. The domain is x is greater than 0, and the range is all real numbers. And so here I have the parent function, the f of x equals log of x. And you can see the domain, x is greater than 0, and the range can be all real numbers. Like I showed you before, here's just some examples of how you can modify and alter some of the logarithmic functions. So like the f of x equals 7 times log of x, that's the red right here. The green, g of x equals log to log of x minus 5, that's the green, it's moving 5 units to the right. The purple right here, h of x equals log 4x, that's the purple right here. And the orange graph is j of x equals log of -2x plus 3, so that's that orange right there. And then like I did previously, I'm going to go through like a specific example. So transformations of a parent function. Right now we have f of x equals 3 times log of negative 2x plus 4. And so you look at this equation and you see that it's going to be a logarithmic function because right there you have the log. And then through each step, you're going to start off by seeing that negative, so the reflection across the y-axis. If the negative would have been in front of the log and out of the parentheses, not affecting the x, it would be over the x-axis. But because it's affecting the x right there, it's a reflection over the y-axis. The 3 right there shows a vertical stretch 3 times its height. There. The plus 4, so the translation, I should say 4, I apologize. The plus 4 is the translation 4 units up, and the 2 right there shows a horizontal compression by 2. So the first step is that f of x equals 3 times log of x. So the graph is vertically compressed by 1/3. And this graph shows it takes the parent function, that f of x equals log of x, and it vertically compresses it by 1/3, and this is the graph that you're going to get. Next step, the graph is horizontally compressed by 1/2. That's the 2 right there. So the new equation is going to be f of x equals 3 times log of 2x, and this is the graph that you're going to get. Next step after that is simply flipping it over the y-axis. So whereas before you had that f of x equals 3 log of 2x, you're going to flip it over the y-axis, and the new equation you get, the new equation you have is f of x equals 3 log of negative 2x, simply flipping it over the y-axis. Pretty simple. Then your final step is shifting it 4 units up. So your equation is going to be f of x equals 3 times log of negative 2x plus 4. So the graph shifts 4 units up compared to this, where it hits the x-axis right there. Now it's hitting it right there at 4. And then your final function is that f of x equals 3 times log of negative 2x plus 4. That's your final function. There you go. It's done.